So Lab5 is about the second order circuits, series RLC circuits, and the first part is about the LC circuit. So here, input voltage, which is a square wave, a 2 peak to peak square wave, in series with an inductor 2.7 millihenry, and I chose the 10 nanofarad. So for the LC circuit, the resonant or the natural frequency is 1 divided by square root of L times C, and of note, the frequency equals omega naught divided by 2 pi. So for this circuit, the resonant frequency is 30.6 kilohertz. You simulated this circuit in the pre-lab and you got this waveform. So you simulated this circuit in the pre-lab, and this is the response you got, and it shows an undamped response. However, in the pre-lab, the inductor you'll be using has an internal resistance of 5.6 ohms. So when you simulate this circuit in the lab, you'll get the underdamped response like this. We'll see this in the lab. So now, here's the circuit. So this is the 2.7 millihenry. Here's the inductor in series with the capacitor, and then the capacitor is connected to the ground. I'm using the brown wires for the ground, yellow wire for the input, and green wire for the output. So we'll be using the function generator. Here's the function generator. To set up the function generator, the first step is utility output setup IZ. And for the amplitude, it's 2 peak to peak, and it's a square wave. And for the frequency, it should be 1 divided by 12 of the resonant frequency. The resonant frequency of my circuit here is 30.6, and 30.6 divided by 12 is 2.55. So 2.55 kilohertz. Back to the circuit. So here's the BNC to banana cable, and here's the T connector, and I'm using the BNC to BNC cable to connect the input from the function generator to the oscilloscope, and a BNC to banana cable to connect the input from the function generator to the circuit. And this is a 10-to-1 probe, which is connected to pin number 2. It's connected to channel number 2, from the oscilloscope, and it's connected across the capacitor. And here's the ground. So now the circuit is ready. So here's the square wave input voltage from the function generator connected to the inductor in series with the capacitor to the ground. Here's the capacitor, here's the ground, and the output is measured across the capacitor. So this is the output. Now we need to apply the signal. So turn on the output button on the function generator, and this is what you get on the oscilloscope. And you can notice that it's underdamped, because the inductor has an internal resistance. This is it for part 1, or for problem number 1, which is the LC circuit.